So yesterday we were discussing a point where we had to send only limited set of arguments to the function. Because if we define a function saying that it is expecting only three numbers or three arguments, only three can be sent, not more than three. Say, for example, if we saw an example where we tried to add x plus y plus z. Okay, so yeah, this one. So we saw this example where we tried to add three numbers and x, y, z were the arguments. And we saw that if less than three numbers were sent, you we would get positional arguments error. Even in the case where we said try to send more than three arguments. So just given a case where we have a requirement that we can send any number of inputs to the function, we have something called as wildcards. Okay, so how the wildcards work is like this. Wildcards. Yep. Okay, these are called as wildcards. So how they work is like when you define a function, you would say that we are expecting random number of arguments. Okay. Uh, the use case is very less. We might not be using this on a frequent note, but if you are trying to generate something more dynamic, probably this is more. This might be required for such requirements. Now, how you define a function saying that you are sending a random number of arguments is by saying this args. Okay, this is called as a wildcard. And what happens in this wildcard is it is an iterator. Say, for example, it can be list, it can be tuple, anything. So you can consider it as an iterator, and then based on that, it will send you the output. So what I've done, I've written one in a function called sum all, and in this I'm trying to use args, asterisk args, and then I'm trying to sum them up all by by doing this. So sum is another function, and I'm using the inbuilt function in Python. And I'm adding all of those arguments in a list and then returning. So let us execute this. So while the execution, as I said, even if you made any error, you would not know until you until you call the function. So I'm trying to send only one argument now. Let us see. So when I try to send only one argument, you saw only one argument is present. The argument value is one, and the sum of that argument is one. Similarly, if I send two arguments, these are the arguments. Like one and two are the arguments, and the sum of those two is three. Similarly, you can add more number of arguments now. So just in case if you want to see what are the args, now in this case I have used print args, right? You can loop over the args also. So how do you do that? Say I'll rewrite the same function, and I'll say for arg in args print arg. I'll say separator is equal to a pipe symbol because I don't want that to come as a new line. Okay. So when I do this, let's see what happens. I executed that. So whatever previous function is present in my memory, that will be rewritten with this new function. Okay. Now I'll just go and execute this part where I have more number of arguments. It did not give me separator is equal to, oh, sorry, it should not be separator, it should be end. I'm sorry, it should be end so that it will not allow that to go as a new line. Okay, that is how you can see all the arguments that are present in your function. Whatever you send, you can send it as a, you can see the output by using this for loop. One thing to keep in mind is this asterisk is present at the input, and if you're using a for loop, you don't have to use any asterisk again. Okay, just keep that in mind. And again, if you are sending all args to some different function, you'll have to send it in the same way. Of course, because this args is not some kind of a list or tuple, you'll have to convert that to list by using the square brackets. That's the syntax for sum. And then, yeah, I think we already saw this. If you want to print all the args, you can use for loop and get all the uh, arguments. As I said, if you don't want to see them in a new line, you can always use end equal to I can put some separator, and when I do this, I'll get all the output. Clear, Tilia?
Yes, clear.
Okay, and you don't have to specify it as args. You can put any name. The catch is that the asterisk symbol is important. So instead of args, I can put it as arguments. It will do the same job. Okay. So it
Okay.
doesn't mean how you define the variable. What matters is if you have put single asterisk or not. That is more important for us. Um, okay, don't need this.
అప్పుడు ఎప్పుడైనా ఇంకా ఒకటి ఎప్పుడు ఆర్గ్యుమెంట్స్ ఇవ్వడమే మేలు కదా అప్పుడు సింగిల్ వస్తు వేసేసి
బేస్డ్ ఆన్ ద రిక్వైర్మెంట్. ఇప్పుడు మీ రిక్వైర్మెంట్ వచ్చి మల్టిపుల్ ఉంటాయి, అన్నిటికీ ఎలా సింపుల్ ఆపరేషన్స్ చేస్తున్నారంటే అలా చేయొచ్చు. బట్ మోస్ట్లీ విల్ నాట్ బి యూజింగ్ దట్. అలా పెట్టలేము, ఎందుకంటే యూ నెవర్ నో. సే ఫర్ ఎగ్జాంపుల్, ఈ కేసులో అన్ని ఆగ్స్ ఒకే డేటా టైప్ లో ఉన్నాయి కాబట్టి నేను సమ్ కాల్ చేస్తున్నాను. బట్ గివెన్ ఎ కేస్ దట్ ఈచ్ ఆఫ్ ది ఆర్గ్యుమెంట్ ఇస్ ఆఫ్ డిఫరెంట్ data type, how would you know which I'm sorry, so how would you know how to handle those data types within the function? So again, that will be too much complicated. So that's why I said, like, we don't use this. But given a case when you're trying to build some libraries where you expect users to send all data frames or all lists, so in those cases, probably you can go and use this args and quirks. Okay. Just before going to keyword arguments, the same way how you have for arguments, the wildcard for arguments, we also have a wildcard for keyword arguments. So before I do that, I just want to go and iterate over what we discussed in dictionary. So what you see in this is a dictionary where you have a key and you have a value. Yeah, key and value. So when I say what are the object dot items, I would get these are the items A1, B2. These are the items. So each item is a tuple. Similarly, the keyword arguments also, so the keyword arguments also behave like this. They behave some kind of a dictionary. How, I'll tell you. So the difference between wildcard of arguments and wildcard of keyword arguments is a double asterisk. So previously we were using single asterisk. In the case of keyword arguments, we'll be using two asterisks. So what would you do with two asterisks is that I would say that I am expecting that the user would send me all the keywords in form of this, A equal to this, B equal to this, like this. Okay. And then what I would be doing is same how I handled what you saw here, right? Key, comma, value, and object dot items. The same thing I'll do it here. Instead of dictionary, I'll put quirks. It is as simple as that. So you can imagine that when you send it as keyword arguments, internally it behaves like a dictionary. Internally it behaves like a dictionary. So so let us see how it works. So I'm writing one function where I'm expecting that the user will send all the keyword arguments. Okay, A equal to 1, B equal to 2, C equal to 3, and so on. That I represent it as asterisk quarks. Again, as I said, like, this can be any name. This need not be quarks. It can be any variable name that you put. It is just a variable. Only thing is that it's a dynamic variable. It's a wildcard variable. I have two asterisk symbols here. I have two asterisk symbols here that we have to note. And then what I'm trying to do is I'm assuming because the user is sending all these keyword arguments, what I'm trying to do is I'm utilizing same like how I did for dictionary. I'm doing it for quarks also. And then I'll try to print what is a key and what is a value. Say, for example, I'm going to call a function. Now I'm going to pass three arguments to it, keyword arguments. First is the name, next is age, next is country of origin. When I send this, it will tell me name is Sanjeev, age is 36, country of origin is India. Same like what you saw here. Correct? You saw in object we have a dictionary. Same in quarks also, you have a dictionary. The only thing is that when you try to do this, sorry, where did it go? What is happening? Yeah. When you try to do this, you may never know what kind of arguments that you have. Okay, I mean, the key names can be different, the values can be different. So when you're writing a function based on some key name, and if you don't expect that key name, then it can be a problem. Say for example, I have written one logic like this. Let me just copy this. I'll say the function name is 2, and after I print this, I'll say uh, print quarks. I'm not sure if it's going to work or not, but I'll say name. I'm representing name as nm. Okay. Let us see if it works or not. Okay. Now what I'll do is I'll just call this function back again. And instead of quarks, I'll say name. Sorry. Sorry. Variable equal to some foo, and then name 2 equal to bar. Notice that your function is expecting this key. Okay, but the user did not send that key. So in this case, again, it might fail. No, see, it is expecting you to send us nm key, but I did not send nm, so it is failing. So if you have such requirements of using dynamic variables, and that there is a key that you're expecting and the key is not sent, you can mark like this. So I'll just copy one more time. I just want to show you the difference. We have quarks, and then I have nm equal to default empty string. What does it say? I think I have to give like this. Okay. And then I'll call the same function again. So if at all you have a requirement that you are expecting one name key, 1 minute. Oh, it is not there in quarks. That's why it is failing. Yeah, so you cannot do it. If at all we have to give like this, yeah. If at all we have to pass it as an argument, you will have to default it. So you have to specify it separately in the function, and then we will have to use it. But as I said, like we will not be using args and quarks to the max knowledge I have so far. Like I did not use it, but it's just there in the Python, just in case if you have any requirement of passing n number of arguments or n number of keywords, then you can go with keyword arguments. Okay. Same is the case with this keyword arguments. We have discussed this. Uh, we can also mix argument and keyword argument. Say I have a mandatory argument. There's a positional argument which is arg1 and then followed by quarks. So I can say this positional argument is supposed to be sent. I'm executing that. So in the positional argument, I'm passing the value 1. In the keyword arguments, I'm passing name, age, and country of origin, like which I did earlier. So if there is a requirement that you have to get the positional argument, you can write a function with mixture of both of them. You can also mix args and quarks. Okay, based on the requirement, you can send anything like that. So just in case if I do not pass the positional argument, then it will throw an error saying that I'm expecting a positional argument, but you did not send it. So that is why it will fail. Okay, so we have covered arguments and keyword arguments. We have seen how we can use wildcards in Python. So we can include them in making the functions. Okay. Now let us continue our knowledge around decorators. Okay. So this is one part of the programming thing in Python, which we have, like we can use decorators for various reasons. Like say, for example, if you have a function, say, for example, we have a function and we want to understand how much time it takes for executing this function. So every cell, if you notice, every cell is showing you the time here. Okay. But it is there only in the Jupyter notebook. Say, for example, if we move to Python Python files or modules, and then if we want to track the time taken for each function, there is a way. What I can do is like I can I can capture the time at the starting of the function, and I capture the time at the ending of the function. I can find the difference between them. Okay, that is one way. But what if I want to make it dynamic? I want to calculate every function which is there in my application. I want to calculate time for everywhere. So I can do the same logic everywhere. In every function, I'll say my start time is this. Say, how do you do that? I'll say start underscore time is equal to time dot now. And then at the end, I'll say print time dot now minus start time. Okay, this will give us the time difference for each function. But imagine if you have like hundreds of functions, everywhere you are writing these two lines, everywhere. So what's the easiest way? You have the same functionality and you want to achieve the same functionality in all the functions. I want this in all the functions. Okay, irrespective of what the function is doing, I don't care. But I want to understand how much time it is taking so that I can improve my application's throughput. So for that purpose, you can use decorator and achieve the same functionality to and apply it for all the functions. So I'll tell you how we do that. Uh, so before okay, I'll tell you how I do that. But before that, I want to tell you about a couple of things. We have something called as sorry. We have some module called as OS. Okay. And just in case if you want to go through all the files that is present in your directory, you can use OS module and walk through the current directory. This is the path where you give your current directory and you can get all the files and folders. This is how you get it. This is not required for now. I'm just trying to skip because I have it here. I'm telling you. Before telling you about decorators, I want to tell you some more about functions. Okay, there is one feature in functions which we did not discuss. Say I have one function here. This is to underscore lower, which to which I'm sending one argument. Okay. And I'm calling one more function to convert that argument to a lowercase. So this is a string. I'm converting this to a lower by calling this function. So if you send any uppercase values to dot lower, it will convert to lowercase. The same thing, I'm going to call my function. I'm going to send my uppercase characters. So when I send that, it is saying that this print is coming from lower function and the output is Sanjay. So and so. Similarly, we can have upper text. It is going to do the same thing. It will going to convert it to uh, uppercase. So if you send any lowercase, it will convert it to uppercase. We have two simple functions. Now I want one more function which through which if I pass upper, it will convert to upper. If I pass lower, it will convert to lower. So I'm going to send function as an argument. So how do you do that is I have a function called wrapper. Okay. In this wrapper, my first argument is a function. Okay. My first argument is a function. And the second argument is the argument which you're going to send to this function. Previously, what we did, previously, we had only function. To that function, we are sending an argument. As simple as that. We are not doing anything peculiar here. But when you're coming to this wrapper function, I'm sending function as an argument. Okay, this is a function. And how we are calling this function? By parenthesis, by putting this parenthesis and sending the argument to us. As simple as that. I did not do anything fancy here. I have a function. We are taking two arguments in which the first argument is the function and the second argument is the argument which you're going to send to this function. So let me write this. Okay, I'll write this. Now I can go and see the doc string. We have covered this yesterday. So the docstring says this is upper function which takes in function and an argument which has to be sent to the function as argument. So the first argument is a function. The second one is a argument which I have to send to this function. So what I'll do, I'll call wrapper first. Forget about this thing. I'm going to call wrapper. In wrapper, I'm going to call one more function. Now, what is the first function? We have to underscore lower. This is our first function. So I'm going to call to underscore lower and I'm going to send one argument. So just in case if I call to underscore lower, sorry, I'm going to call to underscore lower directly and I'm going to pass this argument to it. So what happens as expected, it will convert this junk text to lowercase. Okay. Now I'm going to call the wrapper function. I'm going to call this function here and I'm going to send this argument here. Okay, I did not do anything. See, the first argument is a function name, but I'm not putting a parenthesis. Note, please note that. Okay, I'm not putting a parenthesis. I'm just putting a function name. And then I'm going to pass the argument which I have to send to this particular function. So when I do this, so it will throw the output. This is a lower text. And this is a lower function because you already have this print here. It is printing here as well. Same, you can do this to upper as well. So I have the same function wrapper. Now I'm changing the function from to underscore lower. I have kept to underscore upper, and then I have used the same function. Okay, to underscore upper, and I pass the same argument, and I got the output. In to underscore upper, I don't have any print statements. I don't have any print statements. That is why it is giving only one print. This is more junk text. Okay, are you with me till here? So you can write a function.
Yes,
Yeah. Okay. We can write a function to which we can pass function as an argument. Okay, that is one way. Another way of writing function is you can have one function. Within that function, you can have one more function. Okay, see, this is completely a
okay.
different function. And this function is not available outside. Just like how you cannot access the variables outside the function, this function cannot be accessed outside this function. So let us try to do this. I executed that. I'll try to call inner, I'll say 5. It will throw an error. Inner is not defined. This function inner is present within outer. So it can be accessed only within outer and it cannot be available outside outer. I'm sorry.
Okay.
Okay, you're clear, right? Now what I'll trying to do is how to call this function now. I'll call outer now first. And when what I have done is I have written one function outer. In outer, I have written one more function. And in yesterday's session, we discussed something like, if wherever you have first print state return statement, the next part of the body will not get executed. I'm not sure if you remember that or not, but I just want to show you. Where was that part? I think here. I have discussed this yesterday. So
Yes.
whenever you have first return statement, the next part of the body will not get executed. You notice the hierarchy, okay? All of this
Yes.
is present in the same indentation. All of this is present in the same indentation. So because it is present in the same indentation, this part of the code will not get executed. Okay. Now we'll do something new. What we'll do now is I will take one outer function. I'm going to return another function. This is another function. Let me write it again for you. So I'll say df outer. I'm going to take one variable called x. And first I want to return one function name here. When I execute this, it doesn't understand what is function name. Okay. it will get executed, of course. But if I go and say print outer and I'll say 5, it doesn't understand what is function name. Okay. Now what I'm going to do, I'm going to take the same function. I'll declare what is function name. Now function name is another function. So def function name, I'll take y as an argument, and then I'll return x plus y. As simple as that. I did not do anything fancy. So what I'm trying to do is, when this first function is called, I want you to return a new function called function name. Okay. Now we'll see this in action. Okay. We'll see this in action. Now I'll go back to my original function where I have outer. In outer, I'm going to return a function. This function is nothing but it is returning x plus 5. So x is an argument that is passed to x. X is a argument that is passed to outer, and y is the argument which is passed to inner. So let us see how to do that. Now first I'm calling the outer function. Okay, you cannot call the inner function because, as I said, like when you call the inner function, it will throw the error saying that inner is not defined. Now I'll call the outer function. I'm going to pass 10. Now this add 10 is not a value, it is a function. How do you know it is a function? Because outer is going to return a function name. Okay, when I go and print add 10, it says it is a function located at this memory. This is a memory address. There's a memory address. So it is a function. I can when I print it, I can say it is a function. Okay, and it is a outer function, outer dot locals. So this local means
Okay.
this is available only within outer function. Now what I'll do, to add 10, I'm going to pass a new variable called 6. Why I'm passing 6? Because I told you here I'm going to pass the second variable y. So when I call add 10, this is a function, right? I'm going to call function add 10 and I'll pass an argument 6. So when I print it, I'll get 16 result.
Okay.
Sorry. Okay. This is how it works. I'm going to add one more function now, add x plus 5. I'm taking 2 arguments, I'm adding it, I'm returning x plus 5. Now I can write one more wrapper, just like how we did for wrapper in the case of 2 upper and 2 lower. I'm going to do the same thing for calculate. I'm going to write calculate, wherein the first function is x. And previously I was taking only one argument, now I'm taking 2 arguments. After taking 2 arguments, I'm sending these 2 arguments to the function, as simple as that. So when I said add 5, 8, it is going to send 13. Or I can also say calculate. In this calculate, I'll say add. I'm going to get the same output. So it is same thing, but written in 2 different ways. Now let us come back to decorators. So far you understood, like we have a capability of passing function as an argument or writing one more function within a function, and you can use this, like we can call the outer function and get the inner function, and then call the inner function to get the output. So these are the possibilities that we have in Python. So now let us go to decorators. The decorator is something very similar. Okay, so we have seen how we can pass function as an argument, or we can also declare another function within a function and make use of both the functions. Okay, so similarly, what we can do is we can use a concept called as decorators in Python. So how do you do that? Is just like we did earlier. I'm going to have a make pretty function in which I'm going to pass the function name. Okay, and inside the make pretty, I have one more function where this function is going to get called. It's same what you saw earlier. In earlier, what we had this outer function, right? Previously, in outer function, we are passing an argument. Okay. And in the inner function, you're passing another argument. But here, what we're trying to do is, in the decorators, I'm passing the function directly in the outer function. And in the inner function, I'm calling this outer, whichever argument which I send, I'm going to call this. Okay. So in make pretty is the outer function, which is calling the inner function. And in inner, I'm calling the actual function which was passed earlier. Okay, this is how it is. So I'll just let me write execute it, and then what I'll try to do is I'll try to call the ordinary. 1 minute. Chandra, 1 minute. I'm sorry. So I'm going to write one more function, which is doing nothing, but it is saying it is an ordinary function. Okay. This is my function. So when I call ordinary, it is going to print ordinary. Okay. What I'll do is I'll make use of decorator. How to make use of decorator is by doing this. On the top of the function, I'll say @make underscore pretty. So when you write the function like this, whenever this ordinary function is called, it will not directly call ordinary function. First, it will call make pretty. In make pretty, it will pass the ordinary function. So in this function attribute, ordinary will go. And then it will do the same logic. Okay, so let us see what happens now. Okay, I declared make pretty, and then I'll go and call make underscore pretty. Sorry, yeah, I'll call ordinary again. This is also not required, but just in case, if you want to make use of some dynamic functionality which should be applied to all the functions, you can make use of this decorators. Okay, so you can see when I called ordinary, it is making use of this make pretty decorator. You get this print calling decorated, and then the actual print from ordinary. Okay, you got both of them. It's the same thing like how you call make pretty directly. Instead of calling ordinary, what I'm trying to do is I'm going to call make pretty. In make pretty, I'm passing my ordinary function. Okay, I'm assigning this to one variable. This variable is now a function. When I call this function, you can see the output is same.
Okay.
Okay, it's the same thing. But instead of calling like this, you can just put @make pretty on top of each of the functions that where you want to apply, and then you can do this. Okay, then you can get this functionality. This I already covered. This already covered. Now, uh, before moving further, I'll going to tell you a bit about modules and packages. Okay, uh, module is something which is just a simple Python file. Now, this test.py is my module. In
Okay.
test.py, I have two functions. Okay, so what I can do is I can import these functions directly. Say, for example, if I want to import it, because I have my UDF part2.ipynb in the same folder where my test is present, I can say import test.asterisk, or I can say just import test. Okay, when I import test,
Okay.
it will import that Python file here, or whatever functions that are available here. I can get make use of all the functions that is present in test. Now I can say test dot. So in test you have two functions, right? In test we have function 1 and function 2. I can say function 1. Say for example function 1. When I call this, it will work. Okay, this is the first function. We have value 5. Why we have value 5? Because I have declared something, and I am going to use a global variable. And so we discuss about this global variable. So I don't want to iterate over this. So what I'm trying to do is I'm going to import test
సంజయ్
and
చిన్న డౌట్.
uh-huh.
ఇప్పుడు ఇక్కడ కాల్ చేసావు ఆ .py లో నుంచి ఫంక్షన్ ఇక్కడ. సో ఇక్కడ ఎడిట్ చేసావు. సో
Avadu.
ఆ test.py అవదా?
No, you cannot. You can only make use of functions here, but you cannot go and iterate. You cannot go and rewrite the function here. అప్పుడు ఏమవుతుంది? మీ మెమరీలో ఉన్న ఏదైతే టెస్ట్ లో ఉన్న ఫంక్షన్ ఉందో అది రీరైట్ అయిపోతుంది. ఇఫ్ ఐ గో అండ్ డిక్లేర్ వన్ మోర్ ఫంక్షన్ హియర్, def function1 రిటర్న్. బట్ ఇప్పుడు మీరు ఈ ఫంక్షన్ ని కాల్ చేసినప్పుడు ఫంక్షన్ అని కాల్ చేస్తారు. యూ విల్ నో లాంగర్ యూస్ టెస్ట్ డాట్ ఫంక్షన్. సో దిస్ విల్ బి డిఫరెంట్, దిస్ విల్ బి డిఫరెంట్. సే I will write this in another way. From test import function1. Okay, in that case, I can use function one. Okay, now it's working. I'm getting function one. I'm calling the function one, getting the output. But if I go and declare one more function one in this page, okay, I declared this. What will happen? Whatever I imported from test will get replaced with this new function. And when I call it, it is no longer doing that functionality which it did in test.py.
Okay.
So it is going to replace because they both have same function names, it is going to replace in the memory. It will replace that memory object.
Like
And
variable అనుకో.
same like variable, exactly. Same like variable. So whichever is the latest value, it is going to do that.
Okay.
Good. Yeah, good question.
ఇప్పుడు మనము test.py లో ఎడిట్ చేసినామంటే ఇక్కడ రాసిన ఫంక్షన్ లో కూడా ఆటోమేటిక్ అప్లికబుల్ అవుతుంది కదా.
అవ్వదు.
అక్కడ వేరే
ఏదో ఒకటే పనిచేస్తుంది అగైన్. సో ఇప్పుడు test.py లో ఇప్పుడు నేను వెళ్ళి ఇక్కడ ఇంకో ఫంక్షన్ యాడ్ చేస్తాను. ఐ జస్ట్ యాడ్ వన్ మోర్ ఫంక్షన్.
ఫంక్షన్ కాదు, ఇప్పుడు అక్కడ వేరియబుల్ 5 డిక్లేర్ బదులు 10 ఇచ్చావనుకో. సో ఇక్కడ మనం ఆల్రెడీ ఇంపోర్ట్ చేసుకునేటప్పుడు 5 ఉన్నది, ఇప్పుడు 10 కిందకి మారిపోద్ది కదా.
10 కింద మారితే అప్పుడు యూ విల్ హ్యావ్ టు రీస్టార్ట్ ది అప్లికేషన్ అగైన్. అంటే ఇక్కడ నేను వెళ్ళి రీస్టార్ట్ చేయాలి. ఒకసారి నేను ఇంపోర్ట్ చేస్తాను కదా, ఇప్పుడు ఆ ఫంక్షన్ వెళ్ళి మళ్ళీ అవ్వదు, 5 ఉంటది. ఇప్పుడు నేను 10 పెట్టాను ఇక్కడ చూసారా, 10 పెట్టాను, కొత్త ప్రింట్ పెట్టాను. ఇట్ విల్ నాట్, బికాస్ ఇట్ హాస్ ఆల్రెడీ ఇంపోర్టెడ్, ఇట్ ఇస్ నాట్ గోయింగ్ టు ఇంపోర్ట్ వన్ మోర్ టైం ఈవెన్ ఇఫ్ ఐ క్లిక్ దిస్.
ఓకే,
ఇట్ ఈస్ నాట్ గోయింగ్ టు డూ.
డైనమిక్ కాదు, వన్స్ రీస్టార్ట్ అయితేనే మాత్రమే.
యా కరెక్ట్, ఫస్ట్ టైం రీస్టార్ట్ అయితేనే ఇట్ విల్ రిఫ్రెష్ ద హోల్ cycle and it will get the fresh values. After the import, if you go and make any changes, it's not going to reflect. You will have to restart the notebook. Same goes with any Flask application also. If let us say you have Flask application, you have made some changes, you will have to kill the server, you have to restart the server, like that. Okay. And never do this. Say for example, you have imported function one from a different module, same function when you're declaring in this notebook. This is a very bad way of doing it. You should not overwrite.
Okay.
Okay, we should never do this.
Okay.
You have already imported function one, and then you're trying to replace that function with some other functionality. That's a bad way of writing a code. Okay, so this is called as a module. Whichever is a .py file, it is called as a module. So time is one module. By default, it is available in Python, and math is one module which is available in Python. So whichever is a .py file, it is called as a module. Oh, what is a package? Package is something where you have a sub notebook. Say for example, I have this ANN, artificial neural network. So this can be a package. If I'm going to import something, I don't have a Python file here, but if I'm going to import something, I will need one init file, initialize file, and then I need one more Python file so that I can import it from the outer part. So if I have to show you the folder structure, I'm going to tell you about models and packages at a later point, but because I'm going to import those models, I'm just explaining you. Okay, don't worry if you are not understanding it. I'll explain you one more time. Say for example, I have this. I'm sorry, let me open D drive, knowledge. Training 2. Okay. When you see packages, right, you will have a main function. This is a main function. This is a main py file. And in this main py file, you will have a package. In package, you will have one more py file. So let me open it. I will show you. I'm going to open a new Visual Studio function. Sorry, new Visual Studio window. I'm going to recent. I'm going to go to D drive, I'm going to knowledge, I'm going to training 2. Okay. Okay, so let me close this. Don't require, don't require, don't require, don't require. So this is a folder structure. We have a main file. What this main file does is it imports couple of modules, and it imports couple of modules that are part of my package. Now this is my package. My package, in other words, is a folder. In this folder, I have a py file called as operations. I'm going to import one function that is present in operations. So I'll expand as my package operations. So see the folder structure, okay? You have a main file which is sitting in the main directory. My main directory is training.2. And outside this main, I have something called as my package, which is a folder. Inside the folder, which is we have something called as operations. Now in operations, I have simple function, add numbers.
Okay.
Okay, so you can make use of this module OS to tell what is the file name. When I say underscore file underscore underscore file underscore underscore, it is going to return the operations.py path. Wherever this operations py path is present, it will return it. Okay, and I have this function which is doing nothing. It is simply adding all the numbers. We have seen this. Okay, we have seen the keyword arguments. Sorry, this is a wildcard for arguments. You can send n number of arguments to it. It will sum them all of them, and it will return the output. So what I did, I imported that in my main function. How did I import? From my package, my folder name. In this folder, I have a Python file operations. In this Python file, I have a function called add numbers. Okay, for this import to work, you will need init file. This init file is empty, but Python understands that it can relate that init, because you have this uses initialized thing. It can relate that this package is a part of this training.2. Okay, so that is how it will import. It will make use of imports. So make sure that whenever you have packages, you need to have a init file followed by all your modules.
Okay.
Okay, this is how it is. I'm going to explain this one more time, so let us not deviate. But I just wanted to show you how the module and packages differ. So in short, package is going to have init file followed by Python files. Module is just a Python file. Okay.
Okay.
So time is a module, math is a module. I'm putting it. These are modules present by default in Python. So when I install Python, these files are already there. Okay.
Well,
Now what I'm going to do is I'm going to import these libraries. I'm going to write one function, calculate time. Moments ago, we discussed that we want to find out, irrespective of whatever is my function, I want to find out what is the time taken for each of the function. I can pass any function to it. Add numbers, multiplication, factorial, whatever you call it. For all the functions that I send, I'm going to apply the same logic. What is the start time? What is the function execution time? What is the end time? And what is the difference? End time minus start time. That's the difference. So what I'll do, I'll write one function called calculate time. In this, I'm going to pass the function to which I'm going to execute this call and see how much time it is going to take the for execution. That is a function. And inside this calculate time, I have a core time calculator, one more function. And here I use both keyword arguments and arguments. Irrespective of what I'm going to send, I'm dynamically, I'll take all the input from the user. I'm going to send all the inputs to this function. Okay.
Okay.
Just note, I'm going to take the start time, time.time, end time, time.time. I'm going to take the difference, end time minus start time in seconds. And I'm going to return the core time calculator. Forget about all this, okay? Just what I did earlier. I have a function which will take function as an argument, and I'm going to return one more function. Now I have to declare this new function, core time calculator. I have to declare this. So what I'll do, I'll declare it, core time calculator. What does core time calculator will do? I'll take all the arguments sent by the user. So I don't know how many arguments the user will send. So I'll take args. I don't know how many keyword arguments the user will send. I'll take quarks. Both of them are wildcards. And then to the main function, which was passed, I'm going to call this function, whichever is the main function for us. The argument which was sent, I'm going to call that argument. And in this argument, I'm going to send all these things, args and quarks. Understood?
Okay.
It can be a little confusing, but I want you to write the code, take your time, and see how the relationship is there. So in the main function, I'm passing an argument. This argument is a function I know. This function is being called in a sub function. I'm calling it
Okay.
inside another function. Okay, just that thing you have to keep in mind. And whenever you're calling this, before calling this, I need a start time. After calling this, I need an end time. And what is the time difference? End time minus start time in seconds. That's it. As simple as that. Okay. Now this is a dynamic function. I can pass any function to it. I can pass any number of arguments. I can pass any number of keyword arguments to it. Okay. Now, okay, we'll keep this aside. This is the decorator function. We'll keep this aside. Now what I'll do is I'll write one more function to which I'm going to where I'm going to calculate factorial. So factorial is one more function where I'm going to pass one number, and I'm using math module to calculate the factorial of this particular number. Say for example, if I want to calculate math dot factorial of 10, it is going to give me some value. So this functionality, I have kept it here. Okay, I'll execute this. So factorial of 5 is 120. So what it'll do, it'll 5 into 4 into 3 into 2 into 1. It'll do that. But before doing this math factorial, I'm going to sleep for 2 seconds. I just want to give some space because this model is pretty fast. It is executed in 0 seconds. Okay, I want to calculate the time. Let us say you have some body which is not as simple as this. Okay,
and sleep
it will wait for 2 seconds. Aim chedu.
Okay.
Okay, it will
wait. Fast problem.
So why I'm using this here is I want to write some logic which will take some time. In order to do that, instead of doing that, I'm just asking the computer to sleep for 2 seconds. Don't do anything. After that, you do it. After that, you complete the logic. It is not required. You can comment it. Okay. So I'm going to use factorial. When I use factorial.5, it waited for 2 seconds. Okay, 2 seconds అయిపోయిన తర్వాత it printed the number. Okay, 120. Now, just like how we saw the decorator earlier, ఇక్కడ ఇందాక decorator చూసారు కదా మీరు. Yeah, make pretty. Same like this, I'm going to call this decorator. Now this decorator, what is the decorator name? Calculate time. So how do you call the calculate time? Simply by putting calculate time, and same function which I declared here, I'm going to put this calculate time on top of the function. So wherever you want to use decorator, when you define a function, on top of the function, you have to put this, not while calling the function. At the time of declaring the function, you have to put this. Okay, I declared this factorial one more time with this calculate time. Okay, when I calculate factorial 10, it is going to wait for 2 seconds and then it will tell the output. So it took 2.01 seconds. Okay, same way, if I want to add one more function, say, let us say I'll take this function now. Let us take this function. I'm not importing it. I'm just simply using it, defining it. Okay. And again, here I'm going to use @calculate _ time. Okay. Executed it. Now I'm going to call this add numbers. So what has happened? You have created a dynamic function this is a dynamic function, call a decorator, to apply to any function that you want. Any number of arguments that you want, any number of arguments, any function. So that is when you use this args and quarks. On a general note, you would not be using it. But when you have a functionality of writing decorators and you making use of the decorators to do some common logic, irrespective of whatever the functionality is. So here the functionality is to add numbers, and here the functionality is to calculate the factorial of that number. Both the functionalities are different. Irrespective of whatever my functionality is, I want to apply one generalized term. I want to calculate the time taken for execution. As simple as that. And then I'm going to make use of the decorator and apply the same logic to all the functions. So here it is telling it took 2 seconds, here it is saying it took 0 seconds. Okay, so far so good.
Yes.
Yeah, so uh, it is good to have knowledge on decorators, because in some modules like TensorFlow and TensorFlow, Keras, they might be using some decorators. So if you do not know what is a decorator, then you might have a problem of understanding what that is. So as we move closer towards data science, we can find out if there is any functionality of decorators that we're using. We can make use of that. Okay. So that is why I was trying to tell you. So in the next class, I'm going to talk about classes. Okay. So far, we have seen about decorators and functions. In the next session, we'll be making use of classes, and then we'll start our machine learning journey.